Hello, so today we are going to be talking about Pythagorean identities and how we use those Pythagorean identities to solve trigonometry proofs. So first things first, let's get all of our Pythagorean identities that we have in our toolbox to use. So first is our most obvious one. It comes from the unit circle and is part of the box, and it is cosine squared theta plus sine squared theta equals 1. So this also, when we're talking about the unit circle, is x squared plus y squared equals 1. We use this one to derive all of our other identities. So first, I'm going to put all of our Pythagorean identities with a blue star next to them. So we're just going to subtract sine squared theta. That's all we have to do for the first couple identities. And we're going to get cosine squared theta equals 1 minus sine squared theta. So all that took was some subtraction, and there's another identity. And then we have, we can do the same thing, except we will keep sine squared theta on the left side equals 1 minus cosine squared theta. And right there is 3 identities. So now we are going to rewrite our original cosine squared theta plus sine squared theta equals 1. Sorry, those 2's are not quite right. I'm using my finger. Okay. Now we are going to do some division. So we're going to divide this whole equation by cosine squared theta. And that's going to give us a whole new set of identities. So this is going to equal cosine squared theta divided by cosine squared theta, which is 1, plus sine over cosine is tangent squared theta, equals 1 over cosine secant squared theta. And there's another identity right there. Then we can do some subtraction, and we're going to keep the tangent on the left side. So tangent squared theta, and we're going to subtract the 1. So that equals secant squared theta minus 1. And there's our next identity. Now we're going to do the same process. Cosine, oh, we're still in blue. Back up. Cosine squared theta plus sine squared theta equals 1. Again, this one is super important to deriving all of these. You can't do it without it. And now, last time we divided by cosine squared theta, now we're going to divide by sine squared theta. And we're going to get another set of identities. One being cosine squared theta divided by sine squared theta is cotangent squared theta. Sine divided by sine plus 1 equals 1 over sine cosecant squared theta. Then we can keep the, oh, that's an identity, so it needs a star. Then we also can keep the cotangent on the left side, and it equals cosecant squared theta minus 1. So there's all of our Pythagorean identities, and we're going to use these to solve proofs, and they will be substitutions. You can also use them in solving trig equations. These are super helpful. You need to know these. So all of these with the blue stars, these are our Pythagorean identities. So no need to memorize these because you can derive them super easily. Okay, so now we have our first example of a trig proof that we're going to use a Pythagorean identity to solve. So the equation is 1 plus secant squared theta over 1 plus tangent squared theta equals 1 plus cosine squared theta. So with any proof, you always pick one side, you pick the harder side, and your first step is to change everything into sine and cosine. So we're going to do just that. So our left side is obviously the more complicated side, so it's going to change into 1 plus 1 over cosine squared theta. And that whole thing is going to be divided by 1 plus sine squared theta over cosine squared theta. Then that is going to equal, we're going to get a common denominator so that we don't have numbers and fractions. So when we get our common denominator, it's going to be cosine squared theta plus 1 over cosine squared theta. And that whole thing is going to be divided by cosine squared theta plus sine squared theta divided by cosine squared theta. So now we are going to have our numerator, which is cosine squared theta, plus 1 over cosine squared theta, and we're going to multiply that by the reciprocal of the denominator. Oh, I forgot the theta. Times, so our denominator flipped is cosine squared theta divided by cosine squared theta plus sine squared theta. Sorry. So now a red flag should be going off because this right here is our first Pythagorean identity. So this cosine squared thetas will cancel out and this becomes a 1. So now we have cosine squared theta plus 1 over 1, which obviously just equals cosine squared theta plus 1. And that is what they wanted us to solve for here. So there's our trig proof. So now we're going to move on to our second example of a trig proof that we are going to use a Pythagorean identity to solve. So the equation is going to be 1 minus cosine of x over sine of x plus sine of x over 1 minus cosine of x. And that's all going to equal to cosecant of x. So, picking the left side, obviously. So, when we get our common denominator, we're going to get 1 minus cosine of x squared plus sine squared x. And again, this is just multiplying to get a common denominator. And that is going to be divided by sine of x times 1 minus cosine of x. So then, that is going to equal, so we're going to FOIL this out, and we're going to get 1 minus 2 cosine of x plus cosine squared x plus sine squared x divided by sine of x times 1 minus cosine of x. So then, we're going to simplify, oops, sorry, go back. This right here is a Pythagorean identity. That equals 1. So, for our next step, we can do 1 minus 2 cosine of x plus 1 divided by sine of x times 1 minus cosine of x. So see, that makes it much less complicated. And even more so when we do 2 minus 2, cosine of x divided by sine of x times, that's an x right there, sine of x times 1 minus cosine of x. Okay, so now this looks like we can't do anything more, but we can factor. So we're going to factor out a 2, and we're going to get 2 times 1 minus cosine of x divided by sine of x times 1 minus cosine of x, and you can see, obviously, those cancel out. So then we have 2 over sine of x, and that equals 2 times 1 over sine of x, and we know that 1 over sine of x is cosecant of x, so we get 2 cosecant x, and that is what they wanted us to solve for here. That's our next trig proof, and we used a Pythagorean identity to solve for it. So now we have our last trig proof, and this one is going to be slightly more difficult. It's cosecant of a cosine squared a divided by 1 plus cosecant of a equals 1 minus sine of a. So obviously we're working with the left side again. So we're going to simplify this down, so the cosine squared a on the top stays the same, but then the cosecant a is going to turn into 1 over sine of a, and again, changing everything into sines and cosines. And the denominator is going to be 1 plus 1 over sine of a. So now we're going to do the same thing that we did on the last couple problems. We're going to get a common denominator. So we're going to have cosine squared a divided by sine of a divided by, that whole thing is divided by, sine of A plus 1 over sine of A. Now we're going to multiply by the reciprocals, and we're going to get cosine squared A over, cosine squared A over sine of A times the opposite of the denominator is sine of A over sine of A plus 1. So we can see right here that these are going to cancel out. So now we have cosine squared A divided by sine of A plus 1. So now there's not really anything more we can do, and we see that we need 1 minus sine of A, and we definitely don't have that yet. But if we see right here, cosine squared A has its own Pythagorean identity. So we can substitute cosine squared A with 1 minus sine squared A. So this turns into this, and then we get the numerator turns into 1 minus sine squared A, and the denominator stays the same, sine of A plus 1. And now we can factor this. So the top factors into 1 minus sine of A, 1 plus sine of A, it's a difference of squares. And then the bottom stays 1 plus sine of A. These cancel, and we get 1 minus sine of A, which is what they wanted us to get. Back here. So, I hope this video helps you understand how to use Pythagorean identities to solve trigonometry proofs.